No worries.
Okay.
Here we are. So welcome to another exciting edition of the Focus Follow-Up, our monthly community meetings where we have experts in different areas of the e-NABLE universe sharing their skills. There we go. Sorry, I do this every time. As soon as I hit the record button, it starts playing. Anyways, so today we have our guest is Rick Williams. He's going to be sharing some exciting things with us about a variety of DIY fabrication processes for making devices using new materials and common tools found in your garage and kitchen. And I'm excited to see what he has in store for us. These are things that complement 3D printing and also explore outside of traditional upper limb prosthetics. So without further ado, Rick, do you want to give a little bit of an introduction? I think we all know you here, but if you want to give a little bit of background, a quick overview.
I'm trying to figure out if my screen is sharing.
Yep.
It
We're
is.
seeing
it
lots
is?
of numbers.
Oh, sorry. Yeah, well, you know what? Let me close all this. Yeah, we basically had been talking about some of the different things we're working on. In a perfect world, we would have had Dr. Hurt with us. But he unfortunately was in a situation where he's dealing with personal issues, and his practice is temporarily disabled until that happens. But what prompted a lot of this initial work was he had actually called us because he had a puppy that was a baby Rottweiler and it had a damaged paw. Oh, I'm really sorry. I'm trying to get my screens working here. We have an issue because we're writing iOS apps. And in order to do that, Apple forces you to have a Mac. So we figured out a way to make Mac run on the PC. Yeah.
So Rick, do you want to give a little bit of background of your experience and what brought you to e-NABLE, and just a quick overview?
I have been building limbs now. I think we've been building for 5 or 6 years now. And it's been an amazing journey. We've met some amazing people. And initially, I think when you first start, you're like, well, where am I going to find people? It's interesting, they find you. And I know you guys have all heard my story before, but I had a near amputation. It was actually an amputation on my hand that they reattached. And it was a problem. It didn't initially go well. We had the surgeon who reattached my hand sent me a lot of people who they just couldn't help after they had pretty serious issues. So a lot of them were coming to us, and it's been awesome. But I think it's sometimes difficult to get started. But once you do, it's incredible. It just doesn't quit. Okay, what I'm trying to do at this point is I'm trying to do a slideshow. And I don't want to bore you guys with all this. I think I'll just skip this one, even though it is cool. Let me see here. How can I go to the next one? All right. Of course, I always start with little Marcus because he's my little buddy. I have to do it. Our pets, they watch out for him. This little guy here was kind of an inspiration to me. He has no legs, but I just think he's the most awesome little guy. He basically was born this way, and somebody sent us this video. And every time you see something like this, somebody, they want to help this baby, and we're going to do it. We're going to hopefully build him something that'll work. But I think the message here is sometimes they don't need that much help. You have to kind of weigh it. They get to the point where they just manage. And sometimes a prosthetic will literally get in the way. This one on the right here was very inspirational because, as you all know, they used to just shoot horses when this happened, and sadly, that was just the norm. And the message is always the same. Things in your garage can sometimes do the job. And however silly it may look, it just may very well work. This little guy here found his way with a soda bottle. We have one young lady we've been working with that it took her 7 surgeries before she could actually hold a pencil and use it. And she said, well, why didn't I just do this? So sometimes you have to stand back and wonder if you're getting in the way. This is the little guy we're working with now. It's Faith, little Rottweiler baby, and we're not entirely sure what happened. Her one leg is withered. This is Dr. Hurt and his wife here. And this poor baby went through so much this day. We've got her legs in alginate. Now, I don't know how many of you guys have worked with alginate, but if you have a rambunctious child, or you have a puppy that wants to play, keeping them still for 10 minutes is sometimes not the easiest thing in the world. But what we decided to do with Faith, because we really didn't know what to do, is we went at it from every angle. We went at it from the perspective of, let's make plaster casts. And this is how we do it. We use the alginate because, I mean, dentists use this in your teeth. So clearly it's safe for the kids. We then, after we alginate, we fill it with plaster. We make plaster molds that we can cast from. Now, we're using those plastic or those we're using the plaster molds as input to the vacuum forming. We also scan them, and we make 3D images out of them, along with the 3D images that we make from the actual animal. I want to go through and show you. This is basically the good leg that we scanned in order to build the bad, to build up the bad leg that's damaged. This is a lot of damage here, and it just wasn't repairable. It looked like another surgeon took the actual paw. This would be the equivalent of losing it above your wrist, your arm above the wrist, and they actually stitched the paw to the upper arm. So it complicated things. I think it was just another case of they were trying to help and kind of didn't. They made it actually worse. So what we decided to do was we have ditched a lot of our scanners, our 3D scanners, and we've started using LiDAR. Now, the reason we do that is
what is LiDAR?
LiDAR is
LiDAR on your phone?
Yeah, actually, this is all LiDAR you're looking at. And it does a very good job, not to mention the fact you don't have to drag a PC with you. We get very good resolution. The LiDAR has worked very well for us, and we can take a small briefcase of things with us, and we're able to do a fairly good job. And also, as you can see, we can annotate the limbs with all the dimensions. It does a very good job of calculating dimensions, circumferences, a lot of the things that you don't even get from the more expensive scanners. We have some expensive scanners. But
so Rick, what phone and what software are you using for this?
This came from an old iPhone 6 that we had that did not have LiDAR. We linked it to an iPad Gen 4 that did. So we were able to have them cross communicate just because we didn't know what we were doing, John. It wasn't the best way to do it. But we downloaded some of the freeware right off the App Store from Apple. And we also purchased, I think it was 99 cents for a couple packages just because we wanted to see which ones we liked. We tried 7 or 8 different ones just because we didn't know. But by the time we were done, now the surgeon went out and bought an iPhone's, brand new iPhone, because he thought this was the coolest thing he'd ever seen. But I think that for portability and things of that nature, it makes it super easy to just go in and do your scans, do your thing, take it home with you. So you're not interrupting everybody's schedule by, unpacking large suitcases of equipment. It's very annoying to them. We're able to walk in there with an iPad or an iPhone and do this. It was super simple. But we knew we had to knock the dog out. And that's not something you want to keep doing. So we wanted to do all the captures within, we set it about a half-hour time limit. So we got everything. We got plaster, we got alginate, we got LiDARs. And then we took, of course, these home and dried them because we didn't want to sit there in his practice waiting for the plaster to dry. We found this little rack. It was from an old oven, and it turned out to make it was awesome for drying plaster. But we have a copy here of the bad limb and the good limb, which I always recommend because right now we have a problem with little Marcus again. How do you know how big his arm is when he doesn't have any? So we're borrowing one of the neighbor's kids to size an arm. It's really difficult, and a lot of people don't do it. They don't size the existing arm, and that's assuming there is one, which makes it super difficult when there isn't. We actually take it down to this level. I dissect it down right to the bone level because I want when I'm doing this, I want to make sure I'm not going to harm or damage the dog, but we want to reconstruct the animal's anatomy. And we also have to look at this little chart on the right as to whether or not it's even feasible. And I worked with the vet on this. What we were trying to determine was what are the metrics that we could work within to say, no, we can't really do a prosthetic because it's going to do more harm than good. And the dog just has to, for the most part, have the leg amputated completely before it's going to work. I have another one I'm going to get to in a minute that basically takes this and says acceptable, unacceptable, whether they're actually candidates. And I recommend everybody just screenshot it if you get a chance. Once again, these are different views. It makes an awful lot of sense after you've done the scans to really take the time to embed all of the dimensions right onto the photo. Because after you leave, you just don't remember what you did. I mean, some people might, I don't. And so I annotated all the videos with the physical lengths, circumferences, and dimensions of each of the limbs, so we could actually reconstruct it. I wanted to talk a little about some of the technologies because everybody's always talking LiDAR. I'm sorry, about Mayo. Mayo is not really my friend. I personally don't care for it. We found other methodologies that we're probably going to be announcing to you guys later on. I understand there's always a need for Mayos. The problem is if you sweat, if there's humidity, if there's so many variables that get in the way of Mayo. And I think you guys are going to be really, really pleased when you see what we've come up with, and it really does work. But we're not quite ready to release it yet. We're thinking maybe next week. I wanted to put this in here just so anybody that was interested and wanted a copy of the presentation could just look and see how we did it. So this is sort of a, just a matrix of what we did. And we were really flying by the seat of our pants on this one because this was a little new to us. And once again, sometimes the animal needs help, sometimes it doesn't. I love this one with the fish. Because you've all had that goldfish that flipped over and died. You just pull a cork on him. Sometimes you don't have to have a sophisticated, a rig just to make it happen. Sometimes it's stuff you can find in your kitchen drawer. And this one is really important because it goes into the front and the back legs. We've done a lot of research. Dogs in particular and cats, mostly quadrupeds, will put about 60% of their weight on the front and about 40 in the back. So you always have to keep that in mind as to whether or not it makes sense, to really build an appliance or not to. We just had from the e-NABLE hub, Holly. I know some of you probably read of some of her posts, and she had a little Mastiff baby that they were going to take his leg. So we had a whole bunch of conversations offline. I gave her my email. We've been chatting for weeks. We kind of talked the vet out of that. And now the baby has his paw. And if it doesn't work out, we're going to go ahead and build him an appliance. Sweet little Mastiff pup. The reason I put this one up, and I know you guys have all seen this before, but I want to show you this because this is something, you know, sometimes it isn't always about appliances and sometimes it isn't always about prosthetics. This picture, I love this picture because that little Zoe, that's the baby we lost, sitting with Marcus. Now, what we did is this. It looks like a toilet paper roll, I'm sure. I don't know if y'all can see it. But look. It's probably not going to show up very well on here. But as you can see, the detail here.
Oh,
Now, the way we found out we could do this was
no. Rick, what are you showing us? That's
this is a lithophane.
a cylindrical lithophane.
Yeah, and
There's an
what
image
we've been
wrapped
doing-
around the surface of that. Yep.
Yeah, what we've
Got it.
been doing is we've been putting these on the arms. We
Ah,
actually had I was actually having a video conference with a young lady, and she was telling me, you know, her name was Christia, and I'm Christia. I know a band in California, super band, and they're like a family band, and the last name's Christia. I thought it was. She says, "Yeah, those are my kids." I'm like, "Really?" So she says, "What can I do to help?" And I kind of thought she was full of crap, but she said an hour later, her kids called me, and they supplied photos and signatures. So we burned them right into the arms. So we've been actually making the lithios, building them into the arms of the kids' heroes, whoever that may be. So sometimes it's just cool, you know, to be able to do just the little extra thing, to just make the prosthetic a little more bearable. Long story short, kind of this is like a little bit of a MIDI. I know we're going to talk about MIDI today. I'm kind of all over the place because some of my stuff didn't work. I think some of you have seen this before, but this is the MIDI design we came up with little Marcus, and that's his arm, his MIDI arm. Now that arm really can outperform a lot of drummers because every time he snaps it, it's got a rubber ligament. And when he snaps it, it hits 5 or 6 times. So he can do drum rolls with this thing like crazy. And this MIDI device has 16 channels. Theoretically, you could talk to 4,096 external keyboards or devices with it. It makes an enormous amount of noise to the delight of his parents. But this was originally, when we first built it, we set it up for him. And now we've got him playing keyboards, guitar. We've got him on a lot of instruments. And I think this is kind of a discussion that's interesting to have because it's what led us to change all of our bionic devices to MIDI protocol. You start looking at how MIDI protocol works. You're talking every every musical device on the planet, for the most part, has a MIDI port on it. Now, the MIDI port is basically a musical instrument device interface that allows touch, it allows breath, velocity, all these things that everybody's been complaining about that they want to do with prosthetics. It's built into the protocol. And the beauty is that it's about 40 years old, it's tried and true, and it's free. So we've been converting all of our bionics to MIDI because a lot of the work is done for you. Not only that, you can then take your arm and you can plug into light devices, musical instruments. You can plug into, just about anything that supports MIDI, which is almost everything, because people are really waking up to the power of this protocol. MIDI protocol has been around a good long time. My synthesizer wall is kind of cool. We have Marcus come over sometimes on Tuesdays. We have a music day and we jam. We plug him into my MIDI stacks, and He loves that. He gets to play any instrument he wants. This is an example of, I know some of you have seen this before, but this is a wireless, it's called a WiDi. It's a wireless MIDI interface that goes from my glove. I was fatter then too, by the way, but it goes to from that glove to that device. And you're going to see how responsive it is. MIDI is instantaneous because latency is a no-no for any musician. If you have a 1 millisecond delay, it'll drive you nuts because you're playing and you're not hearing what is supposed to be happening yet. So for anybody involved in music, it's unacceptable to have latency. This device actually has touch. I can tell how tight it's gripping. You can see that it monitors my wrist, all my fingers, my thumb, and I can tie it into just about anything. This one here was built to play 2 octaves on a piano. Now, the reason that was done, and I'm not going to bother you with a video of it, we were very inspired by a man who was a concert pianist and lost the use of his hands 20 years ago. And I have a video of it. It's just heartbreaking. But he now has these gloves and he can play piano again. And he's just sobbing. It'll tear you up. But his ability, this particular hand went to, this was for a stroke victim that had mobility but could not grip or grab. This thing makes up the difference in the strength and allows you to actually physically pick something up when your hand really could go through the motions but would not have the strength of the ligature of the ligaments to do the grip. And of course, everything has to be checked out by puppy there. It's very important because this started out as a doggy scratcher in its early days. And I know some of you guys have seen, whoops, didn't mean to do that. Some of you guys have seen this video of this hand. I guess it's not a video. This is my workbench, just a picture. But that particular hand has 15 servos in it. And we learned very quickly the power utilization these servos take. I personally don't like using servos. And all our bionics, we're moving away from them. And the reason is, not only are they not MIDI friendly, they're stupid. If you take power away from them, okay, they quit doing what they're supposed to do and they just kind of freeze and stop. Secondly, they have no strength. You have to get the ones with metal gears just to get.
So what's the alternative?
We're using motors, standard motors, and we're building metal geared motors, transmissions. The transmissions are incredibly strong. When you park them or you take power away, you cannot physically with your hand turn the transmission output because it's geared down so much. We're doing about 1,000 to 1. And it works really well because where you park it, it stays. Okay. And we'll be showing you more of that.
Okay. Listen, Rick, I just want to point out that we're halfway into the hour. So
I'll hurry.
There's an alert. Well,
I'll
hurry
hurry
or prioritize the material you want to get to.
Okay. These are just some of the initial designs we were looking at. And I know I showed some of you this. This is one of the prosthetics we're looking at getting, building for a dog that we're talking to now on the left. And on the right is what we're converting all of our MIDI, all of our designs for bionics, we're converting now to microbits. Not only because they're incredibly cheap, but this thing will run all day on 3 volts. So from a power perspective, it's awesome. You're talking, it has accelerometers, compasses, it's got a processor, it's got IO. And for 20, 30 bucks, it's super. I know I've put this up before. This is kind of another thing, just to show it isn't always about prosthetics. We were involved in the Positive Life, building the cancer sniffing dog devices. And I know a lot of you had already seen that, but since we were talking about stuff you build in your garage, this was kind of cool. The person gets this delivery device, they breathe in it, they snap it shut. The dogs will tell them whether they have cancer 2 years before science will. I have now some show and tell. I know you guys, I showed you you know, the new leg, we're still waiting to deliver.
Rick, why don't you stop screen sharing and
Okay. Oh, guess who this is? That's one of our sessions. What we have is a few different arms. Oh, what are you doing, hon? We've been working on building a lot of different doggy prosthetics. I know earlier I was going to show you guys this because we were talking about like the Nick finger and things of that nature. One of the problems is powering the Nick. It hurts people, and some of the other ones do as well. You know, when we were talking about it. So we went on Amazon and we bought one of these, and we're finding that this works super well. It's for archers, you know, to release their string. And we did a little engineering on it, but it fits right around the wrist, on the back of your wrist. As you can tell, it kind of works really well as compared to just putting a string around your wrist. I thought I'd bring that one up.
now slow down, Rick. So the idea is that instead of, at that point, you activate the Nick finger by bending your wrist.
But the thing is that it puts more pressure here where it should be, because that's how the archers do it. And the positive thing about it is not only is it a lot more comfortable, but it uses this part of your hand as a lever. And it allows you to do a better job of bending it without the pain of just having a wire, a string, or a harness around your wrist, or even a cuff. Reportedly, everybody's been very pleased with how comfortable and how much more leverage they get out of it.
Have you seen it in use?
Oh, yeah. Yeah.
Did you take a little video of it in use?
We did not, because we had to bring it back. We were basically just testing, because we had to bring it back because we're rebuilding the hand based on, we're going to be building two different hands. It's going to be this one that Nate and I are talking about, because we're taking all these fingers off and we're putting the new finger technology on this one. And so we've got to tear this one apart. This is getting a serious. One thing I do like about this is this ball. Isn't that cool?
Beautiful.
So they can position the thumb themselves. However, it's not active, and we're going to fix that. We're going to put some channels on it, make it active as well.
So Rick, I asked the question about, did you take a video of the archery unit in action, because you are such a fire hose of information, but you often assume that your audience, composed of mere mortals, can see how this all fits together. So I really want to urge you to sort of think about the props you need so that people will get the jokes that you're telling, if you get my drift.
We'll try to do better. We'll try to do better.
All right, so keep going.
A lot of the times, a lot of the people we work with, they're very limited time, and sometimes we have them testing it. We even have a few that don't want to be videoed. Some of them are very embarrassed.
Well, that's fine, but the point is, when you're presenting to us, because I find all of this fascinating, think about what we need in order to understand what you're showing us. Okay, go ahead. Just some helpful coaching.
This is the piano hand, you guys probably saw.
And why is it called the piano hand?
Because this one is designed to handle 2 octaves on a piano. And this thing will actually accept the MIDI controls and play a piano. And
so leave it on screen for a minute. I'm going to be a pest today. I can tell. I didn't sleep much last night. So first of all, there is a piano hand with a MIDI interface and a bunch of
servos. Just servos.
Those are servos. Okay. It's all machined, right? None of it is 3D printed, or some of it is 3D printed?
It's mostly 3D printed. Some of it's laser cut. We have a high-powered industrial laser in there.
Okay.
And we have a CNC machine.
And how many motors are there?
15 altogether.
Okay.
There's an armature.
And
And
how does one control it? Well, no, what
oh, I'm
from
sorry.
the human point end?
To that chip I showed you earlier, the microbit chip. There's actually an
Okay, keep
IO
going
interface.
back, and then the microbit chip is driven by sensors of what sort?
That we're actually changing how we manipulate these now. Instead of myos and reading your muscles, we're putting accelerometers in the arm. So like when they want it, the arm wrist to go left, they turn whatever it is they have left. Right? It turns the thing right. This up and down will open and close the hand.
Okay,
So it's much like
the candidate for the piano hand is someone who has a hand and a wrist, but no fingers.
no hand.
Where does it end?
Say right here.
Okay, so how will they make individual fingers move?
Individual fingers will be by either by the tilting, by tilting the arm in certain directions, which can be programmed to your liking. So what ends up happening is you're taking azimuths and you're taking where this thing sits in space, where the chip is sitting in space, and you can program it to, as you turn it or tilt it, it will actually operate the fingers.
Okay.
And that eliminates a lot of the, believe it or not, a lot of the complexity.
Okay, but you haven't actually put this together with a human who's playing a piano yet. None of this is a complaint. The point is, I'm trying to understand which parts are works in progress and components of a system and which parts are actually tested and integrated.
This is the one you actually saw working on an earlier video with MIDI. And the reason we used MIDI was because that gives you the touch. We can tell exactly, because that's part of MIDI protocol. You have touch, you have sense, you have speed, you have velocity, you have all those things built into the protocol. It's all been done for you now.
Do you want to go back to that video, Rick? Because that's something that might be helpful.
Let's see here.
And I think part of it too, it's we can take another couple minutes on this specific device, and then maybe it'd be useful to zoom out and just look at some of the DIY fabrication processes, some of the materials and common tools that people can orient around.
Absolutely. So this is it here. Can you see that?
No, you're not sharing right now.
Okay, hold on. So this was the video we showed earlier of this hand. It's on this little model here.
Right.
Can you guys see this?
Yes, I remember this
And
now.
this is actually how it works. In this case, it's communicating wirelessly to my glove.
Okay, but so now I understand the state of this project, but in this case, it works with a person who does have a hand and fingers and that face sucker rig that's on the hand, which detects all of the finger
that's just an option. That was basically to show how the hand could articulate, but the tilt and all of that is how we're operating like the new hand that I showed you just a bit ago with the, where did I put it? I got it here somewhere. The Nate, the one I'm working with Nate on. The one that Nate and I have been working on, which I put here, this one.
Got it.
Okay, this one is going to be driven by tilt of your arm and twist of the arm. So if you didn't have a wrist at all, it would be just fine. As long as you had something you could tilt.
Okay, so Ben is actually hoping that you're going to get to the scheduled content before we run out of hour. So I'm going to stop asking you here about this.
Oh, no, I apologize. I'm probably not doing a very good job of, I'm probably not doing a very good job of articulating how these work because it is a little new to us too. And one of the problems is that we don't have a lot of presentation material put together yet, or videos to show you, other than, you know, some of the works in progress, like some of the doggy prosthetics. This is one we're working on for a pup.
Mhm.
It's rubber.
Okay, hold it. That is a doggy prosthetic.
Yeah.
I'm
part
guessing
fits
that
into
the
the upper
long
leg.
parts, Rick, I want to model a confused viewer. You're
Oh.
holding that upside down, right?
It would normally go like, if the dog was going forward, it would be like this. Okay.
Oh, so that's the foot at the bottom.
Yeah, their
Okay,
leg
I
would
got
go
it.
in here.
Got
and
it.
This would be the foot.
Okay.
Gives them some spring, you know.
Got
And
it.
the
And what's
foot,
that made out of, Rick?
this is just made out of ABS and rubber. The bottom is rubber and the top is ABS fused, or TPU, I'm sorry.
And the
And this
TPU
is
is
just-
3D printed.
Yeah, we 3D print TPU a lot.
Mhm.
We finally
Okay.
figured out how to do it. It took us a while. On our printer, it was a nightmare. You know, we have some alternate foots that fit on it as well. So you can actually change the foot
Mhm.
for like a running foot or whatever.
And
Yeah.
those are designs that you found online or you guys put
No,
together?
we're just doing the best we can to, you know, like this, Jeremy will probably like this. This is how we started it. This is all thermoform. I took one of the thermoform sheets that we've talked about in the past. And this was just started as a 12 by 12 sheet. And we heated it. And then when we dropped it on the thermoform, this is how we got the shoulder.
So you got to slow down again. You had a plaster cast, which is what you dropped it on?
Yes, correct.
Okay.
We had to cast his like chest and shoulder area. This is a different dog, but like his chest and shoulder area,
Got it.
right? If they didn't have any leg at all, and then we then can make the appliance and plug in different types. All these different things plug into it. Like this was a foot.
Mm-hmm.
So he's got a spring in it and everything.
Mm-hmm.
And so once we have the shoulder made, okay, and it fits properly, then we can actually plug in anything we want here. And
So I'm beginning to understand your methodology. For this dog, for example, you start by making a plaster cast of the dog's stump, if you will, chest and stump.
yes,
And you do that by getting the dog to settle into alginate or by,
yes, because it's safe. It's very safe.
No, I know
Dennis
it's
used on his
safe.
kid's mouth.
do you have to anesthetize the dog, or was he,
That depends on the dog. You need 7 to 10 minutes.
right?
And if he's not going to put up with that, chances are, yeah, you're going to
Okay.
have to.
So you're working with a vet, the vet calms the dog, so now you've got alginate, then you pour plaster into the alginate,
Yes.
and now you take a printed or purchased plastic sheet of the sort that's in your hand. Where does that come from?
This came from this sheet here came from Amazon.
Okay,
And it's
so you can
called,
buy thermoformable plastic
yes.
and you put it in the oven,
Yeah. My wife's oven, she's really pleased about that.
okay, until it gets sort of floppy.
It kind of sags, you know, it kind of sags a little bit. And that's how
Is
you
the
know it's
plaster
done.
in the oven with it, or?
No.
Okay, so you take this now
Honey,
floppy, the
Can
saggy
you bring
sheet.
can you bring the box? Yeah, it's a vacuum forming box it's basically a homemade vacuum forming box.
Great.
We
So
don't
let's
have
take a look at
Jeremy's
that.
money. And she's going to bring it over right here.
Okay,
Great.
And the vacuum forming box, you hook it to your vacuum cleaner.
mhm.
Is how we did it. Thank you, hon. I appreciate you. And it looks like this. I'm hoping you guys can see this.
Yes,
There's
yes.
pegboard. And there's a hole here. And that's where you put your vacuum cleaner. And the underside looks like this.
Yep.
These are all homemade. And then you take the sheet and you put it in, you make one of these. Ours happens to be a 12 by 12. And you can get this framing at like Ace Hardware. It's for mobile homes. And then we use bulldog clips. So you take the sheet, you put it in this thing, you put this whole thing in the oven, and there's two of these that are being held together by these bulldog clips. So you see how they're two together? And the sheet is stuck in here. Then you drop it, after it's hot, you drop it on that box, which is a vacuum, and it sucks it right down, and it does this.
Got it. Got it.
And then when you have this, now you can do anything from epoxy to fiberglass, which we hate to do because, you know, but in a pinch, we have fiberglass just to make the outer thing, and then we'll do it with something else. But it works beautifully, and we've had excellent luck. And I know you guys have all seen it, so I'm kind of tickled by it. Oops, with my finger stuck in there. This is a finger we're working on. So this is the end result of the one we'll be delivering.
Rick, can I just
those
suggest
two.
that you stop your screen share since we're not using that? That
Oh,
way
I'm sorry.
we'd be able to see you more, a larger version of what you're showing.
How's that?
Yeah, better, thanks.
Even found a little boot.
Okay,
But
so
the
slow
thing
down,
that-
please.
Beauty of this is they can change the foot any way they want to. So because this is an M8, they can screw in anything they want or change the length as he grows. And it's all ready to go. And it looks like, you know, the stuff, it actually looks like carbon fiber, but it isn't. It's and I'm going to say this wrong. I've tried to say it to Jeremy. It's called
Cridex.
Cridex, yeah. And that's what we're using. But it's kind of mean, a little bit meaner than ABS to use. But once you got it done, it's absolutely worth it.
Okay, so this Cridex. Well, okay, so this is something you're working on now. You haven't seen it on the dog yet.
Well, we're waiting for Dr. Hurt to come
Right.
back to work. Yeah.
Okay. Okay. I'm asking these questions because it's hard to understand how these pieces all fit together
Yeah, because
conceptually.
we're trying to make them very modular
Yeah.
so they can change their mind. See?
Yep.
And if you make them modular enough, as the dog grows, okay, you don't have to start over.
Right.
You just replace the piece that he's outgrown.
Cool.
Rick, I'll just say I can tell, I know you're already working with Nate, and I can tell you and he are going to get along great. You just got to figure out the challenge of how to make this all understandable to us mere mortals.
Oh, I'm sorry. I know. I'm trying to get, this is actually a mouse trap. Oh, you guys would like this. So what we're doing is we're trying to do these things as cheaply as possible because we don't have a budget. And that's really what this is about. The processors and the bionics that we're doing, I think you guys are going to be surprised how well they work. You get a lot more variables than you will with a Mayo.
I could see that.
Because after you mix it together with the MIDI kind of makes up for the difference. I mean, you're talking with MIDI, you have breath instruments even where you know, people that play woodwinds can actually accentuate their breath. It's
right.
It's that level of detail in MIDI.
Yeah, that's like what you were saying before. I mean, the MIDI
Yeah.
protocol is designed to capture those different aspects of expression, and
Yes.
that really does map well. And you also, I had never heard you talk about the low latency aspect of it, but that also is very interesting. So
Right.
definitely
And
consider.
now it can be wireless, which is huge. We're using wireless WiDi now, and we're having really, really good luck with almost, I think the latency was very, very, very realistic and reasonable, even for the musical instruments. We're trying hard to, believe it or not, some of the main interest people are having is in the musical instruments. A lot of the amputees really want to play. We've had a lot of guys that have lost arms that were musicians. And so it doesn't sound like it's a big deal, but it really is to them to be able to play again. I know it was to me. But, you know, the vacuum forming changed a lot for us because I have nothing against 3D printing, but it is a long process. It takes a long time, days, weeks. And if something goes wrong, like with us, when they pulled our meter out after a 7-day print, it's inconvenient. But this has really helped us just to get something that's a little better than the plaster cast and usable. And almost for free. It's just not that expensive. A sheet of the ABS, I want to say we got it for $7 or $8 for a package of, I don't know, 2 or 3.
Right.
But we've been trying to buy medical grade only because we're cautious. I don't think there's a real difference, but we're finding that we're having really, really good luck with it. I mean, you mix it with, you mix it along with the 3D printing, and it just opens up so many options. Now we're writing our own software. We're doing a lot of it on a lot of it is some of it's Android, some of it's iOS. A lot of it is Windows, but we're only doing that for the IoT aspect for communications. That's kind of my forte as a software design. So we're getting there. We're getting there. The problem is Apple tends to make it very difficult. You actually have to have a Mac, which we don't. So we kind of had to improvise and make our own virtualized. And we're just doing the best we can. That's really it. We're just doing the best we can. And
well, I think the constraint of spending little money and working with available materials is a very helpful constraint, because what you come up with is likely to be useful and adaptable by other people. Mm-hmm. That part is great. I actually think that many of our university members are spoiled by the fact that they have access to all sorts of high-tech, cool technology, and they end up making stuff that is only available if you have access to all sorts of high-tech, cool technology. Good learning experience, but it doesn't make it out into the real world. On the other hand, Rick Williams, PhD, communicating what you are making possible in such a way that other people can pick it up is something I really want to invest in, because you and Nate both have a way of saying, here are 50 amazing things I've done, and I get about 30% of each of them, and I'm running as fast as I can, and understanding it doesn't actually take me that close to being able to deploy them. We have a community of people who we believe would be interested, some of them, in actually learning how to do these things. And for that, we're going to really have to think about how to take a slice through some of the things you're doing and saying, let's pick one that the community could, in principle, actually adopt and use, figure out how to present it to them, figure out what kind of documentation or video or tutorial or workshop they would need, see if we can actually get them to adopt it, and then we iterate on that process. There's a human engineering thing that is harder, especially for the people who are good at the mechanical engineering, than the mechanical engineering in some ways. And until we crack the code on that, this is going to continue to fascinate and dazzle, but we're not going to be fulfilling of our mission of actually getting these kinds of devices to people who don't live down the block from Rick Williams, PhD.
What we're trying to do is get working models, because I think that really helps.
That would be great. That's great.
It's so much easier to explain how something works when it's not this, it's an idea. But when I can say, look, there it is, see how that's how, and they can pick it up and they can touch it and it actually does something, it really takes a lot of the, it takes a lot of the pain away. unfortunately, we're about a week away from that.
Well, that, again, it's all miraculous. Video is another good way of helping people wrap their heads around what we're talking about. But you'll notice, I don't think Jeremy or I have gotten tired of these presentations. I learned something each time, but I want it to be more than entertainment for Jeremy and me. So
Well,
that's,
I figure if I'm bad enough at it, you know what?
well, yeah,
we're working it, and eventually we will have working models. The problem is we're waiting for parts. We're always waiting for parts, and we'll get there. And I actually, we had Marcus's mom, who also has no hands or feet, and she came over yesterday. She is our conscience. She sits down with every device we build and critiques it. And we're very careful to do that on purpose. And we always go to the amputee meetings. We're members of all their communities. We go to their meetings. We're invited. We put them on the table, play with it. No, I'm afraid I'll break it. If you break that, then I haven't done my job right. Okay, so no, please break it. Whatever it takes, just tell us what we're doing wrong and tell us what we're doing right. And it allows us to change our trajectory real time.
cool.
And I think that gives us the most, feedback, positive feedback we've gotten, is people who would be getting these things.
Sure.
So
I'm gonna have to take off, everybody. So I'll catch up with the recording. It should still be continuing.
thank you, Ben.
Okay, thank you, Ben.
And I know a lot of the times that it is difficult to articulate these things without a model. It's just kind of out there. And you're
Okay,
using
well, listen,
acronyms.
seeing work in progress is great for seeing work in progress, but it tells me that we've got other things we need to do if we're going to translate this into a real contribution, which I believe you. I think we'll get there.
Yeah, I think so. And I think a lot of the builders out there are going to find that they're going to want to do this simply because it's easier in some cases.
Well, and I think that the veterinary niche that you've opened up is going to be a really good place to develop this also, because the stakes are lower, the vets are going to be more interested.
Yeah,
and
they're not afraid of being sued like they are with other technologies. They are terrified. I understand that. The veterinaries are a lot more willing to try something new. They don't have to go through FDA approval and all of that.
Yeah.
And so it's a really good place to test materials, to test, a lot of the things we're experimenting with. And
okay, well, give our best to Dr. Hurt. Really, I'm genuinely interested in getting his perspective on this.
Yeah, he's an awesome guy, and we're real sorry that it happened. His baby is still not doing great, so he's
Okay.
He's just out of touch, and I'm sure he has a lot of things to worry about that aren't about this leg, but he has agreed that he would like to to speak to you guys and chat and contribute. He's an amazing surgeon. He's probably one of the best in Florida. We're very lucky he called us.
And Rick, I've forgotten, where in Florida are you?
St. Petersburg.
St. Petersburg. Okay.
Yeah, we're about 20 miles from Tampa.
And what's on the opposite side from Tampa? What city is on the opposite?
Bradenton, Sarasota is on the opposite. That's south.
It's funny. So I was working with a group at the University of Florida at Tampa. In fact, I still have a connection to them. I'll try to hook you up to them, because there's a terrific maker community that is interested in e-NABLE. Okay, we will follow all conversations to be continued. Rick
and like I
Williams?
said, I'm sorry I don't have more to show you, but I think you're gonna love this new fingers.
I don't doubt it. I don't doubt it. I'll look forward to that.
I think it's the best thing we've ever done. These fingers.
Okay.
We calculate it'll have almost 10 times the strength of the existing fingers.
Wow. All right. Standing by.
Thank you
It's,
guys for putting up with me. I know I wander.
That was all good stuff. Thanks, Rick.
My wife always balls me out for it.
all right, see you later. Bye.
Bye.